as soon as I expect them to be. Okay. Now one of the problems is that, of course, as soon as I finish this class, I pack up and go to the Birmingham campus, so it can't load while I'm packed up. It has to have internet access, a router or something, and I'm away from these. And then I get over there, I'm teaching that class. It should upload while I'm teaching that class, but for some reason it doesn't. I don't know if they don't have a good node in that building or what, but they usually don't finish uploading. So then it's Friday, and last Friday I was having an infusion. I couldn't get anything at Kirkland, so I couldn't do anything there. This Friday I'll be on Birmingham campus. I hope I will be. Well, actually, I'll go over that too. Okay, anyway. I'll even turn on the projector for you today. Let me go over a couple of things. One, something coming up tomorrow, okay? Tomorrow is L Day, Lawson Day. It's not quite our homecoming. It's sort of the spring fling type thing that we do, but it's similar to what we do at homecoming. In the fall, we do again in the spring. Okay? Starting at 10 o'clock tomorrow, if you're on this campus out there, just same level as the library. Before you go to B building, there's a little courtyard type area down there. You come in the parking lot and come in the student services entrance. It's those stairs that go down right before you get to that end of the building. You can go to it. There's going to be food. There's usually music. There'll be information tables, maybe, sort of fun activities going on. That's from 10 till 2. And the food, there'll be grills going, hot dogs, hamburgers, chips, drinks, that kind of stuff. Okay? Now, but no desserts. But there is dessert coming. From 12:30 till 2, that's the last part of that, you can go out to North Campus, okay? And you've probably never been there before. But the loop that goes around the campus here, if you come in around this way, there's a Millsap building there, and then just past the Millsap building, there's a road that goes to nowhere, it seems like there, okay? Take a right there and head out there. And I'd say it's a quarter of a mile at least. At least, okay? And then you'll see some buildings show up out of the woods there. And there's a nice parking area, not too recently paved, but nice parking area, and plenty of room if you're driving. And then just past that, the building there where maintenance and that kind of stuff is, and shipping and receiving, that's where building construction is. And we have a building construction major here who gave me this. So they are come and meet tomorrow from 12:30 to 2, come and meet Mr. Hitchcock, the instructor, and the students, including Daniel, and see some of the great construction projects they participated in this year. What do you say, 7 houses?
We did 7 houses with motor blitz in a week.
Okay, in a week for Habitat for Humanity. Fantastic, okay? There will be dessert, okay? I know you want to see the building, but there'll also be dessert, okay?
We don't have those buildings.
Huh?
Those buildings are off-site. But we have
We have
a building there.
Yeah, right.
And we have one that's actually built that we frame for roofing inside the building itself.
Yeah, so it's a nice area over there. No one ever knows about it. It used to be building construction and horticulture were the only 2 academic things there, and horticulture is no longer, so y'all are there by yourself now.
Yep.
But they'll have brownies, cake, ice cream, cookies, donuts, and more. Okay. So that's Building G. Just head north on that spur that goes off the loop, and just keep going. You'll think you're going into nowhere land, but just keep going, and you'll find. Yeah. And actually, now people don't know this. Do you know somewhere past y'all is a pond back there?
Yeah, we've been there.
You have. Okay. I wouldn't go past this time of year. I would go in the wintertime. Huh?
There's snakes everywhere.
Yeah. So I wouldn't go past this time of year.
You go through the woods.
But in the wintertime, it's safe.
The path is really
Yeah, that's but they say they used to catch some really good fish out there. Yeah. So anyway, don't do that tomorrow. Because this next season has started. There could be plenty. So go and see it. It's worth the time. Do any of you want a flyer to remind yourself? Okay. All right. Have friends that might want to go see it.
I've got plenty.
He's got plenty. You want one?
yeah.
Anyone else need a flyer? Okay. All right. And Courtney came in, right? Anyone else come in while I was yakking? Okay. Which is just like always. Okay. So take advantage. Enjoy L Day tomorrow. I've already trying to remind myself, don't fix a lunch tomorrow. Don't fix a lunch tomorrow. But I'll probably tonight pack up a lunch and then go, why did I do that? What's that? I would not put myself through that torture. I mean, I would not do that. Okay. All right. All right. Any questions on math of anything that we've done so far? Oh, and by the way, let me say this too while I'm thinking of it. One of my classes yesterday said they just had opened the student course evaluations. Have y'all noticed that? Okay. So check your emails. Is there a link that takes you right to it?
It's in your email.
That's the easiest way to get there. Check your emails. Click on the link. You go right to student course evaluations. Okay. Please do them.
They've got one for maintenance, library,
Okay.
and then all your classes.
Right. So, yeah, your classes you'll be asked for, and then certain classes are linked to other areas like the library, maintenance, food service, registration procedure, housekeeping. I can't think of all the things it could be, but, there's several things. You might be asked to do one or two in addition to your student courses, the courses you're taking. Please do them all. I get feedback from you every time we meet, whether you realize it or not, how you're responding. And by the way, this class is becoming one of my favorites because y'all participate probably better than any other class. Early on, I didn't feel like I was getting across, but y'all have really made my heart feel good, because you seem like you really, and not just one or two, but, all of you seem to be participating, so I appreciate that. And so I get feedback, but you see people in maintenance and housekeeping and library, they don't always get feedback. So they need to know how they're doing. I really want to know how I'm doing. I also want to know how my other instructors are doing. So please do them all, because I use those when I'm doing their evaluations at the end of the year. So please do the student course evaluations. They're open now, ready to go. Now, if you want to wait until you see your final grade, you can do that. But please don't forget to do that. I can remember when I was an undergraduate, by the end of the term, in that last final, the brain clicked off. I was on the way home already, whether I was still on campus or not. So please don't wait until and then forget to do it. If you're likely to forget, do it now or do it soon. Huh?
It's like 50-something questions per course.
Yeah, and they don't really take that long.
They don't take long.
Yeah.
You see the number and you go, oh.
Yeah. So don't let it scare you. It doesn't take much time. What would you say? Have you done yours?
I did all of mine.
And about how long?
Hours.
Really? Okay. Most people say 5 to 10 minutes, so evidently you read yours a lot more carefully than most. But good.
Do it.
Please do it.
Just hit the top.
Right. Good. I'm glad. All right. Good deal. All right.
We'll throw trick questions in there.
What's that?
We'll throw trick questions in there. Like do not or do.
Yeah.
And if you just click the top one.
Yeah. Okay. There are some that I find interesting. I know that people click without looking. One is the instructor sits while teaching or something like that. Okay? And I have had one of my adjunct instructors, he's no longer here, but he was here for a couple of years, who was literally in a wheelchair. And yet he got checked that he did not sit while teaching. And I know he did. He couldn't get up. So I asked another guy who can't get up, but he usually does it, who's in a wheelchair but not confined to it. He said, no, I never get up. Oh, yeah, I get good marks on that all the time. So be honest and go with it. That one I think is a ridiculous question. Because I have to, if I'm operating this, go back and forth. So I do sit while I'm teaching, but not always. Okay. Speaking of which, I'll stand up. All right. Any other questions before we get going? All right. We're on page 925. And just to remind you of what's about here, we had done example 6, but the slide set example 6 only had one example. Your text has 4, so we were going to do the next 3 from your text, unless you don't want to do it. Okay? So y'all ready to go? This is on page 925. It's called Factoring by Grouping, and let me get my pen activated. All right, here we go. Here's 6ax plus 24x plus x a plus 4. Okay, and it asks you to factor that one by grouping or grouping, whichever you prefer. Okay, what would you do first?
6ax plus 24x.
All right, here's my deal. Okay, you're going to group 6ax and 24x. And grouping things, put them in parentheses. Now, here's the deal, folks. After the parentheses, if that's a plus sign, leave the plus sign out so you don't think you've already factored. You know it's not. If that's a minus sign, include the minus sign. But if it's plus, you don't need to include it. So you do the next 2 terms. And by the way, factoring by grouping only works when you have an even number of terms. Usually 4, okay? But you can do it with more, but it has to be an even number. Okay? What do you notice about the first group?
6x.
Okay, a common factor in that first group. Okay, time out. I should have done this to remind you. Okay? You look at the entire polynomial. And I look at that and say, oh, there may be a common factor. This has a 6, a and an x. That's a 24x. Yeah, I see some common there. There's an a. Oops. There's an a there, but not there. There's a 4 there, but not here. No, there aren't any common factors throughout. That's why we break it down and group it. Group it into pairs. And in the first group, we do see a 6x. Factor that out. What do you have left? A. A little louder. Plus 4. Excellent. And then here you have an plus a plus 4. Hey, I see another common factor. A binomial factor. What's it? The common binomial factor. A plus 4. That's common to both terms. And what do you have left? 6x plus 1. Don't forget that plus 1. Because if you don't include that, you'll never get that one back again, okay? If you just left at 6x and then multiply this through, you're not going to get the original. You won't, okay? But just think of this as understood 1 there, so that's where the 1 came from. You can write in the 1 if you want to. It doesn't hurt. You can multiply by 1 anytime you want to, but that's where it came from. Okay? Does that make sense? And you see they got a plus 4 times 6x plus 1. Good for them. And then they check it by foiling. Let's just do it quickly and see. First, 6ax, there it is. Outer, plus a, there it is. Inner, plus 24x, there it is. Last, plus 4, there it is. So yep, you picked up every time. Okay? Nice to check it. I always like to check because I hate to make mistakes. And if I can find I made a mistake, I want to correct it. Checking will help you do that. Now, some problems, the checking is harder to do than the actual problem. Sometimes I'll skip it, but most of the time I'll check. All right, 2x squared. Are there any questions on that? Okay, 2x squared minus 10x plus 3xy minus 15y. Okay, did I copy it right? Good for me. Okay. Any common factor? Always the first thing to look for is common factors. Things are looking promising here. I see two even numbers. Oops. So no common factors there. Nope, not numerically. Oh, there's an x, there's an x, there's an x. Oh, but no x there. Okay, so no common factors of x. There's two y's here, but none over here. No common factors. Yeah, what do we do with a four-term polynomial? What do you do with a drunken sailor? Oh, that's another point, okay? What do we do? Group them, okay? Group those two and those two. Again, when you have the plus sign, group them, leave the plus sign out. If there's a minus sign, be sure you include that minus sign. Okay? What you notice here? 2x is a common factor, leaving you what? X. Second? Minus 5. Perfect. Next? Plus 3y. Why not? What do you have left? X minus 5. Doesn't make you feel warm and fuzzy inside. What do you notice here? Common factor of x minus 5. Pull it out. And what do you have left? 2x plus 3y. Done. And you can foil it and check it. Good thing to do. In fact, they do it, so we'll do it. But let's just check and make sure we got the same answer they did. We do. And then just remind yourself how to FOIL. First, 2x times 2x is 2x squared. There it is. Outer, x times 3y is 3xy. There it is. Minus 5 times 2x is minus 10x. There it is. Minus 5 times 3y is minus 15y. There it is. Yep, we got them all covered. Our answer checks. We feel really good about that being the right answer. Okay, D. T cubed plus 2t squared minus 3t minus 6. Okay? Typically, what do you look for first? Here's David. That's what we look for. We look for David. Okay. And you who came in, I want you to make sure you understand L Day is tomorrow from 10 till 2. There will be food out here near the library, base of the B building, first floor. Oh, by the way, I should say this too. I don't know, have any of you been in the B building lately? Most of you probably don't go there. Okay? Go in the B building. Their blue tape art show is on display, I think. I think it's still up. Have you seen it? Go in. It is amazing. I haven't seen it this year, but I've seen it the last several years. I hope to go tomorrow and see it. It is amazing what they do with, blue painter's tape? You familiar with that? Okay? They just coat the wall with it. They cut out with the stylus, a knife, something like that. The thing, and you get a negative image. Those people are talented, really talented. It's amazing what they do with blue tape on the wall, just on a concrete block wall. Go in the B building. When you're there getting your burger and chips and stuff, just go on in the B building. You'll probably need to go up to the second floor, but I think even the stairwells are going to be covered. They were last year. Just incredible art. It's like murals. It's like street art almost, only better. It's incredible. Go see it. I've seen a few posters. I hope they still have them up. Okay. What would you look for first here? Okay, he's going straight to grouping. Always look for common factors. A brief glance at that, you see there aren't any. There's common factors in the first three, but not in that one, in these. But yeah, there's no T here.
Well, there's no T there.
Yeah, so no, there's no common factors in the whole polynomial. Then you group. Okay? And this one, because that's a minus sign, include it in the group. Plus, you don't need to. Now, this looks like you factored it. You haven't. All you did was grouping here. Parentheses are used either for factoring or for grouping. In the first group, what do you notice? Yes, a common factor of t squared. Factor it out. What do you have left? T plus 2, or 2 for t. Never mind, never mind. Next, minus 3. And what are you left with? T plus 2. Now, the next little note, the caution, the one that flashed up on the screen first, tells you to watch out for those minus signs. They will sneak out there and trip you up any chance they can. And so please be careful of this. You did it right there. Next. Common factor of t plus 2, so pull it out. And what do you have left? T squared minus 3. Now, frankly, I often and always look at this last term to see if there's any way I can factor it anymore. You can. So far, they haven't given you any you can. Later, I almost guarantee you they'll sneak something in there that you could take another step. So watch out for that, too. Any questions on those? Okay? They didn't check, but you certainly can. Anyone want to see that checked? Or slow blocked? Okay, never mind. Okay. That's factoring by grouping. And here's the caution. Be careful with signs when grouping. In a problem like example 6, there were 4 parts of that. It is wise to check the factoring in the second step before continuing. Always check. And if you pull out a minus sign, remember both signs inside have to change. Pull out a plus sign, nothing changes. Okay? So, watch for that. All right, so here we start over and summarize what we've been doing. Factoring a polynomial with 4 terms by grouping. Okay? Now, you can't have any even number of terms, but usually we're going to be dealing only with 4. I don't like step 1 here. I think there's a step 1 before step 1, and that is check for common factors in all the terms. If you don't have any, then go to this. Okay? If you can't pull out any common factors from all the terms, then see about collecting terms into 2 groups, 2 in each group, and make sure each one has a common factor. Now, if the way you group them, it doesn't, look about exchanging 2. Okay? That's legal to do. You can exchange the whole term, see if that will give you. Okay? Now, once you've done that, you have the groups factor within the groups. The reason you do, you're looking for common factors in each group, factor out the greatest common factor from each group. Hopefully, that will yield you a binomial factor in both groups. That's common. If it's not, you can't factor by grouping. But most of them, I would hope they would give you can. So be careful with your signs. If necessary, and this is what I said up here, rearrange terms. If step 2 does not result in a common binomial factor, try a different group. Okay? I would say if you can't pull out a common factor from a group, then try rearranging. Okay? And go from there. All right, here's example 7. It's funny, they gave you all those examples, then gave you the steps. I would have thought the steps would have come first. But notice, too, you have your marginal exercises. Be sure you do those. Those have the answers at the bottom of the margin. Here's example 7. And this is very similar to the one in the text. It's just the variables are different. So this is almost like the one in the text. In the text, they use x, y. Here, they use a, b. All right, what do you notice here? Okay, no common factors. Good to check. Okay, it looks close. This is even, that's even, that's even, that's odd. This has a 3 and a 5. That has a 5. This has a 3. That has neither a 3 nor a 5, only 2. So no, there's no common factors. There's A's here, here, and here, but not there. There's B's here and there, but not in these 2. So no common factors. So what might you try next? Group. And how would you group? Okay, he's grouping this way and that way, I take it, right? What do you notice in the first group? Anything? Two. Oh, I see. Okay. A common factor of 2, what do you have left? 5. A squared. 6. B. In the second group, what do you notice? Just an A. And what do you have left? This isn't looking good, is it? Minus 8B. There's no common binomial. You grouped okay, you factored okay, no common binomial. Give up, throw up your hands, not factorable? No, please don't do that, okay? Let's start over, almost. Yeah, I'd say start over. Okay, erase all the ink. And let's rearrange the terms. You know, there's several ways to do it. What would be one way that you would see? The 10 and the 8? Okay, let's do that. Let's see what happens. All right, we'll have 10a squared. Now this is a minus 8ab. Then what? Second? Okay, well, let's write the other two down. Minus 12b plus 15a. Let's see what happens, oops, with that. Okay, I'm going to need that. I'm going to leave it. I didn't mean to write it, but it's okay. Now you want to group again? Okay, let's try it this way. Now this time it leaves off with a minus, so include that in the group. All right, what do you notice in the first term? First group, sorry. 2a. And what do you have left? 5a minus 4b. Okay. And in the second group? Okay. Now, Rachel is here. Okay. I certainly see a 3. Now, I'm also sort of looking ahead a little bit, and since this one leads with a 5a here, I kind of want to, don't include the minus sign when you pull out, just include the 3 here. Okay. Because you see, that will leave you a 5a positive. If you pull out the minus sign, that'll make this 5a negative. So, but if you don't see that, you can go back and correct it later. But if you can see it, do that first. In other words, mentally put these two, okay? Or write them out, either one. So what did you say you had the common factor? Plus 3, is that what you said? Okay, and what are you left with? And rearrange those if you need to. Do the positive one first. 5a, and then you have a minus 4b. Hey, 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 it works. We've got a common binomial factor, so what do you do next? Yeah, pull out the common binomial factor, 5a minus 4b, b, and what you're left with is 2a plus 3. Is that the only way you could have done it? No, there's other ways too. You could have combined this one with that, okay? And that way you would have pulled out a 5a and combined these two and pulled out a minus 4b. And that would have worked too, okay? It just would have had the common factor, the other one, the 2a plus 3. So there's several ways to do them, but don't give up if the first way doesn't work. Try rearranging, and after a while, if you can't see any way to do it, then you can say not factorable. But be sure you try rearranging first. Any questions on that? Okay, they do check in the book, so let's us check here too. 5a times 2a is 10a squared. And let's see, yep, there it is. Then your outer is plus 15a. Pop, there it is. And then your inner is minus 8ab. Yep, there it is. And then your last is minus 12b. And there it is. So you can have them rearranged when you're checking. As long as you got all the terms and you keep the sign with the term, you're fine. Any questions? All right, good deal. Now again, example 7 in the slides only had one example. Oh, wait. Sorry. I forgot we haven't done these. All right. Factor by grouping. So working as before, we get 10a squared minus 12b plus 15a minus 8ab. And when you, what are they going to do next? They did the same thing we did and factored out a 2 in the first group and a in the second group, and they got no common binomial factor. Rather than throwing up their hands and quitting, they say, wait a minute, let's rearrange. This does not work. These two factor terms have no binomial in common. We'll group another way. Okay, don't give up. So they rearranged, and did they do it the same way you did? Close. They did 10a squared minus 12b plus 15a minus 8b squared, 8ab. Y'all had those last two reversed, but it was fine. Perfectly fine. So when you group here, as far as I can tell, oh, no. They regrouped again. I'm sorry. That was the first group. I'm sorry. I thought they regrouped. They regrouped and did the 10a squared and the minus 8ab, which we didn't do. We did it the other way, didn't we? So let's see if this way goes. What do you notice in, okay, first they're going to group those. Oh, they did it all in one step. In the first grouping, let me back off and let's do it this way. Let's group these two, and because it's a plus sign, we'll not include that. And what do you notice in the first group? Anything? Second, 2a. This isn't the way we did it, is it? Yeah, it is, isn't it? It practically is the same way we did, right? So I'm not going to go back through that again. Okay? Yeah, that's how we did it. It's just that they rearranged the last term. We did minus 12b plus 15a. They did plus 15a minus 12b. So it comes out the same. Okay, so let's see how they do. Let me go and erase what I was starting to write. And they grouped, and when they did, they had 2a times 5a minus 4b plus 3 times 5a minus 4b. There we have the common binomial factor. Factor that out. And you have left 2a plus 3b. Done. All right. Now, notice they only did it at 1. In the book you have 2, so let's do the second one from the book. Wait a minute. Okay, here we go. I thought I got rid of that, but I didn't. Okay. 7b. 2xy plus 12 minus 3y minus 8x. What would you do with that? Say again? Okay. First look for common factors, The 2, the 12, and the 8 have a common 2, but the 3 doesn't, so that won't work. The others don't even have that many in common. Doesn't look promising, does it? Okay. Second? I can't hear it. Split apart the 2x in the first one? Group them like that, is that what you mean? Okay, if you group them like that, you can certainly pull out a 2 in the first group. In the second group, you can't pull out a thing. That's not going to happen. Yeah. Okay, how would you rearrange? 2xy.
Negative or minus 8x.
Minus 8x. That looks promising.
Plus 12 minus 3y.
Right. Okay. Let's see what will happen there. What can you pull and group them like that? Okay, let's see what happens. What can you pull out in the first? 2x. What does that leave you with? Y minus 4. Okay. Plus. Pull out a 3. What does that leave you with? 4 minus y. Not quite the same, but awfully close. Okay? Now, I know what to do. I don't know if y'all know what to do, but let me make a suggestion to you. Okay? If it's not quite the same, why don't we go back here and rearrange these terms? Just those two. And make it do we have it like this before? Yeah, minus 3y plus 12. Rearrange those last two. And now when we group, include that minus sign. Watch those signs. They'll sneak out there and grab you. And what would you pull out this time? Negative 3. And what would that leave you with? Y minus 4. Yes. That will do it for you. Okay? So now, what do you notice? Common factor of y minus 4. Pull that out. And what do you have left? 2x minus 3. Good deal. Okay. Now, might take a couple of rearranging, but that worked out well. Okay? They do check it, so let's us check too. The first is First is 2xy. There it is. The outer is minus 3y. There it is. The inner is minus 8x. There it is. And the last is plus 12. There it is. Yeah, it works. Did quite nicely. Okay. Let's see if they have another caution. They do in the book. Let's see. We already did this problem. That's the one. That's the screen I should have been on. Nope, they don't do the last caution. Use negative signs carefully when grouping, or a sign error will occur. Always check by multiplying. I think that's good advice. Okay, let's look at our concept check at the top of page 927. Fill in the blank. To factor a number or quantity means to write it as a blank. What would that be? What do we say factoring was equivalent to? Which one of our 4 basic operations? Division. And when you divide, what are your 2 results? Your result up here and what you divided. Those are 2 factors of what you had. So I think what they mean is to factor a number or quantity means to write it as a product. It was together, you pull it apart, and now it becomes a product. I think that's right. Factoring is the opposite or inverse process of, if it's division, what's the opposite of that? Multiplication. Fantastic. Number 2, an integer or variable expression that is a factor of 2 or more terms is a blank blank. That would be an Evelyn. No, an Evelyn Basant. No, what would that be? Okay. All right, good deal.
I'm not staying. I
Oh,
have to head back to work.
okay.
And also to know that next week on Monday I won't be here because I'll be on the field trip with
Oh.
criminal justice.
Okay. We haven't talked about it yet. We'll probably have our test on chapter 13 Monday. How does that sound to everybody? Yay! I thought it sounded good. Okay. But you can make it up when you come back.
Okay.
Okay.
All right. Thank you.
All right. What do y'all think? We're getting into 14 pretty deeply now. Don't you want to go and finish 13 while you got it fresh on your brain? Fresher on your brain? Now, she just turned in her quiz. I'd like to have all the quizzes in. If not today, by Monday. You need to turn them in before you can take the test. You think you can do it? Okay. Now remember, if you turn it in today, you can get those bonus points for those last few. If you wait till Monday, bonus points are out then. Okay? Remember we said that? So, what you think? Monday test? I started to work on it between my last 2 classes, and I got started on and remember something else, and remember something else, and never got back to it. So hopefully I'll get it done sometime tomorrow or Monday before class. Okay? You okay with test on chapter 13 Monday? Okay, let's go for it. All right, number 2 under concept check. An integer or a variable expression that is a factor of 2 or more terms is a blank blank. Integer or variable expression that is a factor of 2 or more terms is I think it shows up in the next sentence. For example, 12 blank a is a common factor. If an integer or variable expression that is a factor of 2 or more terms is a common factor. I think that's what they're fishing for. There may be several words you can put in there, but that's the one that comes to my mind. For example, 12 is or is not a common factor of both 36 and 72. You answer. Is or is not? Second? It is, okay? Since it blanks evenly into both integers. Divides evenly into both integers. It divides into 36 by 3 times, into 72 by 6 times. All right, then do any of the problems or exercises 3 through 10. Do any of the ones from 11 through 20. Do any of the ones between 21 and 24. Do either 25 or 26 or both. And then do any of the problems 27 through 38. Then do any of the exercises 39 through 64. Do some of every group. There's a concept check at the end. So try to do any of the odds, any of the exercises 65 through 70, and any of the exercises 71 to 94. Those are the factors by grouping. All right. And then it says relating some concepts here. You can certainly do those if you wish to, 95 through 98. All right. Any questions? 14.1. Okay. Let's move on to 14.2. Oh, wait. That's not what I want. Okay. 14.2. What do you get? Another day older. Okay. Take a while to load. Oh, there it is. And let's get the slideshow set up from current slide. And still factoring in applications. 14.2, factoring trinomials. Okay? Factor trinomials with a coefficient of 1 for second degree term, for the second degree term, and then we'll factor such trinomials after factoring out the greatest common factor. Okay? So we're going to start with the easiest of the trinomials, those with coefficients of 1. Then we'll graduate just ever so slightly by first pulling out greatest common factor, which you always look to get first, and then try to do the trinomial that way. Okay? So, and by the way, just judging from how y'all performed on your extra credit problems, a few that I've graded so far, I think 4 of you turned it in. Y'all are doing really well on this. Have y'all had this before, or you just taught yourself? Okay. Doing quite nicely. Now, I have a little bit different way of factoring. If you have something you like, you understand, it makes sense to you, don't let anything I say confuse you. Do it the way you've been doing it. If you get right answers, go for it. How I do mine, how did you multiply binomials? What do we call it? A method? Foiling it, okay? So how I try to factor trinomials is to unfoil them, okay? Now, I've never seen that in a book, okay? But it seems to work okay with me. So here's what I do. Now, I don't always spell it right when I'm unfoiling, but let's try it. Let's just imagine that this can be factored into 2 binomials. So we're just going to pretend we know they exist, okay? Now, I start with the first term. What's the only possible factorization of x squared? X times x. You got it. See, we're already making great progress here. Okay? Now, where I look next, it is the outer, well, it's not quite the outer. I go to the last. Okay? So I don't spell it right. Okay? I'm undoing it. I go to the sign of the last term. What is that? A plus. Now, what do these signs have to be? If that's a plus, these have to be, okay, they either have to be both pluses or both minuses. How do you tell? Look at the middle term. It's also a plus. So that means these two have to be plus and plus. Okay? So there's the second thing. Look at the sign of the last term. Determine what these two signs are. They're plus and plus. Now what we look for. Let's look at that last term. We want 2 numbers here that multiply to be 12 but add to be 8. 2 numbers that multiply to be 12 but add to be 8. Second? 6 and 2 will do it, won't they? Okay? 6 and 2. And of course, what do we do next? Check. By 4. X times x. X squared. X times 2 is plus 2x, 6 times x is plus 6x, 2x plus 6x is 8x, and 6 times 2 is 12. Bingo, except you can't say that in Alabama. Okay, so that works, right? Huh? Now we can? Okay. Okay. I didn't have it worked as a better joke before, so. All right. So that's how we do factoring in fact, do they do this? Do they say unfoiling? No, they say undoesing it. Okay. I prefer unfoiling it. Okay. Now, they gave a different example for 1. Oh, no. Okay. They do a lot of stuff here. Please read this. And if this helps you see it, you understand it better than what I've said, go for it. We've just done example 1, and we got an answer. Okay? They show a lot more stuff than I do. Okay? Let's see. Oh, yeah, let me erase this so we can see how they do it. That would be good. I've been talking about how they do it. Look for 2 integers. Yeah, but they wait until they start off with this. I don't start off with this. I start with the first, and then the last, sign of the last, and then we get to this. Look for 2 integers whose product is 12, whose sum is 8. Only positive integers are needed since all the signs are positive. Yeah. That's one way of doing it. I like my technique better. It's more, to me, more logical. But everything's good here. So what are the possible factors of 12? 12 and 1, but when you add those, you get 13. They did it not the order I would have done it. 4 and 3, that gives you 7. 6 and 2, that gives you 8. Stop right there. We've got what we need. The two factors here will be on the outside, and they must add to be what's on the inside. Okay? To me, doing it in a table, you have to know what you're doing to make it make sense. If you do it the other way, you're seeing what you're doing, I think. From the list, 2 and 6 are the required integers, just thus x squared plus 8x plus 12 is x plus 6 times x plus 2. We got it without having to do all that verbiage, I think. Okay, check it, foil it, and sure enough, you get your original. Good deal. Check. Okay. Now here's the note. In example 1, the answer x plus 2 times x plus 6 also could have been written x plus 6 times x plus 2. Why? Multiplication is commutative. It doesn't matter what order you do. Because of the commutative property of multiplication, the order of the factors does not matter. And they say, always check by multiplying. I think that's a good advice. Okay? Now, let's move on to example 2. Ooh, this looks like not quite the same one in the book, but it's pretty close. All right. I don't know if you like my method or theirs, but let's just assume we're going to have two factors here, two binomial factors. And where do we start? The first term. Well, it's the only factorization for x squared. X times x, okay? Write it in that way, okay? X times x. Now, where do we look next? The sign of the last term. What is it? Plus. So that means these two have to be the same. In this case, since the middle is negative, they both have to be negative. For a plus at the end, meaning you have to either multiply plus times plus or minus times minus. They have to be the same. Look at the middle term to decide. And we are deciding minus minus. Now we're looking for two numbers that multiply to be 18, but add to be 9. Second? 3 and 6. You got it. And now it's almost redundant to check because we almost know it's going to work. X times x is x squared. Minus 6x minus 3x, sure enough, is minus 9x plus 18. Fantastic. Now, I don't see any reason to set up a table and that kind of stuff. Later, you might need that. But here on these, unfoil. Just do that. See if you can get it. Okay? They do the table. Okay? And we just checked it. I just did it real quickly. Let's erase this and see how they did it. Find two numbers, and they jump right to the end, and it works in this problem okay. In other problems, it may not work okay. You have to, I don't like having a different method for every type of problem. I want one method that works pretty much across the board. And I think doing it the way I said will be a little more flexible. But sure enough, this works. We're looking for a positive product and a negative sign, so we consider only pairs of negative numbers. Yeah, we went through that too, but without having to write all that down, okay? And then they did a table. We don't need to do a table. We could do it. And frankly, I don't do the tables the same way they do, but it's perfectly fine. I start with 1 and 18, 2 and 9, 3 and 6. You know, I do 1, 2, 3, 4, you know, missing any numbers that won't work. And when you add them together, sure enough, that gives you your minus 9. So if you like this method, go for it. Use it. It works. Okay? The required integers are minus 6 and minus 3. So we have x minus 6 times x minus 3. Checking it, foiling it, you get x squared minus 9x plus 18, which is what you started with. that's your answer. This is the check. So be careful. Always recognize what your answer. The last thing you write may not be your answer. Okay, go ahead and check. Okay, they did a check. Good for them. All right, that was, I hope, example 3, was it? No, that was example 2. I thought not. They skipped example 3. Shame on them. Okay? So let's us do example 3. So which page you want to do it on? This page or let's do it on this one. Okay. Here's example 3 from the text. X squared plus x minus 6. Okay? Now let's assume that we hope that it will factor. And where do we start? First term. Only possible factor for x squared. X times x. So far these have been easy. Okay? Now where do we look next? Sign of the last term, and what is that? Negative. That means these two signs have to be, say again? Yes, they have to be different. Okay? Positive and negative. I agree with you. I'm going to use the term different. Otherwise, I use same. These are different. You'll see the reason for that in a second. So we can put plus minus or minus plus. It doesn't matter. I heard you say plus and minus, so we'll put it that way. Now, we're looking for two numbers who multiply to be minus 6. Well, certainly the minus is going to work. But this time, okay, with the signs, they add to be a 1. Or, and this is why I said the term different, their difference is 1. Okay? That's why I said the signs are different, so this time we take the difference, not the sum. Is that okay? Okay? So two numbers that multiply to be minus 6, but their difference is 1. 3 and 2. Now, we can put the 3 in either place and the 2 in either place. Which one do we choose? Who wins up here between the plus and the minus? The plus does. So therefore, put the bigger number with the plus, smaller number with the minus. You see? So put the 3 with the plus and the 2 with the minus. Okay? Now, what do we always do? Check it. Forward. Check my forward. X times x is x squared. Outers. Minus 2x plus 3x is plus x, and then minus 6. Now, if you had not done the stuff I did before and had put the 2 here and the 3 there, when you did the checking, you would come up with a minus x. Right number, wrong sign. So what do we do? Change the signs. If you had put a 1 and a 6 here and multiply it out, you get the wrong number. So then we change the numbers. Okay? So those are little rules I use. If you get the right number, wrong sign, change your signs. If you get the wrong number, change your numbers for that middle term. Always check, because it will help you big time. So that was example 2 in the 3 in the text, and they did check it. So let's us check it. Oh, we did check it, didn't we? Okay. So we got x plus 2 times x plus 3 times x minus 2. Now, am I talking too fast on this? Is this making sense? Okay. All right, good deal. All right, let's do example 4. All right, here we go. Example 4. First thing I always do is just make an assumption, hope that we're right, that it can be factored. Okay, and where do we start? First term, and what's the only factorization for x squared? X times x. Very good. Okay. Where do we go next? Sign of the last term. And what is it? Negative. What does that tell you about these two signs? Again? They're different. They're opposite signs. One plus and one minus. So I don't care which way you write it. Plus and minus, minus, plus, I don't care. Now, because they're different signs, I'm looking for two numbers that multiply to be 10, but their difference is 3. 5 and 2. Is that what you're saying? Okay. And which goes where? Do you care? Second? 5 what? I can't hear. Which way? On the first one? Okay, 5 here and 2 there. Is that what you said? Okay. What are we going to do next? Check it. Yeah, FOIL it. Okay. So first gives you x squared. The outer gives you minus 2x. The inner gives you plus 5x. And the last gives you minus 10. I like the first and the last, don't you? So x squared. And when you combine the two middle terms, what do you get? Plus 3x. What do you see is wrong? The sign's wrong. Okay? So therefore, let's change signs. So we're going to make that the minus and make this one the plus. Okay? So let's go back and do it again. The first is x times x is x squared. That checks. The outer is plus 2x. Doesn't matter. Let me erase. Okay. Plus 2x. The inner is minus 5x. Oh, what? Sorry. I realize I'm in the wrong place. Okay, here we go. All right. X times x is x squared. The outer is plus 2x. The inner is minus 5x. And the last is minus 10. Then when you combine the middle terms, you get x squared. That stays the same. That's good. That's what we have here. When you combine these two, what do you get? Minus 3x. Ding, 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 ding. Yes, that works. And then minus 10. Yes, yes, yes. Okay. So even if you guess wrong and put the wrong sign with the wrong number in place or whatever, when you FOIL it, that will tell you whether you made a mistake. And if you pay attention to the FOILing, if all you're off is by the sign, like we were, we had a plus 3x, we needed a minus 3x, change the signs. Now, if we had the wrong number, change numbers. Okay? But if you have wrong signs, just change signs. Okay? Good deal. Make sense? All right. And we checked it and it worked. So that was example 4. Okay? Let me erase this so we can see how they did it. I'm sure they did it very nicely, but so they jumped right in. This time we need to consider positive and negative integers. The product is negative 10, whose sum is negative 3. And that's absolutely correct, okay? And they put down the factors, a plus 10, minus 1, minus 10, plus 1. So you do all the possibilities there. Funny how theirs always is the last one that's right. You know, they don't guess very well, do they? Okay, never mind, I'm just kidding. Okay, and that's what they choose, so it's minus 5 and 2. So that's x minus 5 times x plus 2. That certainly works. It certainly does. It seems like it's a little too much work for me, okay? I'm lazy, okay? When you FOIL it, that's what you get. And when you see it's the same answer, you put a little check mark by it. Isn't that neat? Okay. Now, let's move on to example 5. What you reckon you're going to do here? We're going to try it. What we do first? X times x. Where do you look next? Sign of the last term, and that's, what does that tell you these two signs have to be? The same, and since the middle one is positive, they both have to be plus. Now we get to a problem. Two numbers that multiply to be 9 and add to be 3. There are not any. This is not factorable. No solution. How do they say it? This is example 5. No sum. Okay? So what they do cannot be factored using only integers. We also call that a prime polynomial. Okay? So that one is not factorable. You can't do it. There's no way. Okay? Now, let's see, I'll show you how they do theirs first, and then we'll come back and do the B. Both factors must be positive to give a positive product and a positive sum. We need only consider positive integers, and that's 9 and 1 and 3 and 3, but the sum of the factors 10 and 6. No way you're going to get a 3 out of either one of those. So none of these pairs have a sum of 3, therefore the trinomial cannot be factored using only integers. It's a prime polynomial. Okay, now they skipped 5b. Let's us do 5b from the book. K squared minus 8k plus 11. Okay? I don't know if it's going to factor. I do, but let's pretend we don't. Okay? If it's factorable, what's going to be the first factor? K times k. Perfect. And then we look at the sign of the last term. What does that tell you? Second? Yeah, they have to be the same, and since the middle term's negative, they both have to be negative. And now comes the question. What are the possible factorizations of 11? 11 and 1, that's all you got. Anyway, that's going to add to be 8? No way. Stop right there, hold the presses. This one also is not factorable. Okay? And how they phrase that is, they say no pair of integers. They say it's a prime polynomial. I like to say not factorable. But you read what it is in the back of the book, go with that. If I understand what you're saying, you're going to get credit for it. Well, we already close to being out of time. How in the world could this happen? Okay? Now, where we'll begin next time is this. Do we have time to do it real quickly? Yes, we do. Okay. This is the summary. Factor trinomials with a coefficient of 1 for the second degree term. In other words, the leading coefficient is 1. I don't know why they have to put so many words there. Find two integers whose product is the last and whose sum is the middle. Okay? Both integers must be positive if C, B, and C are positive. Both integers must be negative if C is positive and B is negative. Only one integer is positive, one negative if C is negative. Yeah, all that's true, and I think you see it play out. Okay? Now, I guess we don't have time for this one. We'll begin next time with example 6. Okay? Now, let me give you a few homework exercises. You have the ones in the book that we didn't do, the ones in the margin we didn't do, and then in 14.2 on page 935, great, thank you, we have, you can do 3, 5, 6, any of the ones 9 through 12, and I think any of the ones 13 through 24. I think you can do any of the ones 25 through 42. And probably stop there. We'll pick up the rest of those next time. Good deal. Any questions? Good deal. Now, did everybody hear? I know some people came in late and some people have already left now, but we are planning to have the test on chapter 13 on Monday. Okay? So come in with questions if you have them, or see me before class with questions, and then when we start the test, you hopefully will have, okay, don't know if I told you before. Yeah, I think I did. At the end of 13, there's some good study type stuff you can look at, and that was there's a chapter 13 test at the end that has all the answers, I think, in the back of the book, and there's review exercises covering each of the sections. We didn't do scientific notation, so don't worry about that, but the rest of them, good things to study at the end. Good deal. Don't forget L Day tomorrow. Food, desserts, building. Can you get any better than that? What were you going to say? Building G, yeah, right. I was looking at buildings. Okay. All right, good deal. Thank you so much. Good deal, thank you. Giving me lots of grading this weekend. Thank you very much. No, I'm glad. Oh, to Andrea. Oh, you probably didn't see your score because I didn't put it out there yet. Very good on you. 101. Yes. Yes. Fantastic. Oh, we just recorded that.